Okay, so today we're going to be looking at logarithm. It's a very popular topic in hard math, in A-level math, in YF math. So it's a very popular topic. I would like you to pay attention to get it. Now, logarithm. Now, when you have something like this, when you have log xy is equals to n, what it actually means is y raised to power n is equals to x. That means this raised to power this will give you this. Do you get it? That means that log 100 base 10 is equals to 2. It means 10 raised to power 2 is equals to 100. Okay, so that is the use of the logarithm. You get it? So when I give you something like this, so if I have, I can put this in the form of log um, 100 base 10 is equals to x. You know that the thing will now be what 100 is equals to 10 raised to power x. And if you use exponential formula, exponential method, you are going to have 10 raised to power 2 is equals to 10 raised to power x, and 2 is equals to x, and x is equals to 2. So that is the first thing you need to understand about logarithm. So, so whenever you hear logarithm, sorry, whenever you see a logarithm and you have x, y equals to n, it means that y raised to power n will give you x. Y raised to power n will give you x. It goes like this, raised to power this will give you this. That means y raised to power n is equals to x. So once you understand this, you have done with logarithm. So the next thing we are going to be looking at is rules of logarithm. What are the rules of logarithm? Forgive my hand, terrible. What are the rules of logarithm? Just like indices, they are like the opposite of indices per se. For example, when you have log um, um, x, a base x um, plus log b base x. So when they have the same base, it's going to be log x multiplied by log x, log ab is x. So remember in indices, when you have x raised to the power a multiplied by x raised to the power b, your answer will be x raised to the power a plus b. It's like the reverse process. In logarithm, when you see addition, you multiply. And in logarithm, when you see addition, you multiply. The same way when you see multiplication in indices, you add. So that is the thing that you should know. So the first one, you can call it addition law or multiplication law. But the main thing that is there is that when you see addition, you multiply the whole thing. So for example, if I have log 5 is 10 plus log 6 is 10 is going to be log 30 is 10. That is it. So the second law, when you have log a is x minus log b is x is going to be log a over b is x. It also came from the ideology in indices. When you have x raised to power a divided by x raised to power b, it's going to be x raised to power a minus b. So in indices, When there is division, you subtract. But in logarithm, when there is subtraction, you divide. Okay? So another, you can call this a subtraction law or division law, or you can call it both. So another rule again of logarithm, I can call it power law. So when you have log A, um, okay, let me call it A, log B base A raised to power X is the same thing as X log B A. You see what I did there? The power will come forward. Example, when you have log 10 2 raised to power 5, it's the same thing as 5 log 2 is 10. So we get it now. We can call it now power law or reciprocal. It's not reciprocal law. We can call it power law. But just understand how it works. Okay. Now let's move again. Log to its own base. Log. Another law is a log to its own base. So when I have log AA is going to give me 1. So log AA is going to give me 1. Remember, this raised to power this give me this. That is why A raised to power 1 is equal to A. That is why log to its own base will be 1. Now, having that ideology, another rule is that log um, 1 log 1 base anything is going to give me 0. How? Remember the rule again. This raised to power this will give you this. And anything raised to power 0 is 1. So if I have A raised to power 0, it's going to give me 1. So whatever the base is, so understanding that log 1 is 0 and log to its own base is log to its own base is 1. There log 0, we'll find out. Now, another one, just like the power law, I like having people knowing this. When you have this log, base power, you can call it base power or power of the base. How do we do that one? This one, you have log A B raised to power X is the same thing as 1 over X log A B. Remember, if the power is for the logarithm, you take it here, it just be X. But if the power is for the base, it's going to be reciprocal of that particular thing. So a quick summary again, when in the logarithm, the addition rule, when you see addition, you do what? You multiply the logarithm. When you see subtraction, what do? You divide, you subtract, you subtract. When there is a power to the power to the logarithm, you can bring it to the other side and it will give you this. Okay, so another rule that we say again, log to its own base will always give you 1. Log 1 will give you 0, and base power will be reciprocal, then multiplied by that particular thing. Then the last law we are going to be looking at is change of base. Change of base. You want the base change. So let's see, for example, we have log A is B. We can decide to have a common base and have log A is X all over log B is X. It can be in form of this. But mostly we do this so that we can make the whole thing to have the same base when you can have, you can actually have another way you can do it. Log A, B can be in form of log. I want it to be for to be in this the base of this. I can have log A B. Yes, I can have log A um uh, this part that I want to get there. I want to get different log. Okay, so you can have a 1 all over log is another change of things, 1 over 3 log A. So how do we get this part? We can just say log AB is the same thing using the change of this to as log AA all over log BA. And log to its own base is 1. It's on 1 over BA. We are going to solve some questions and that will help you to have a deeper understanding of this. But we cannot solve a lot of questions. I'm going to make another video detail explaining some of the rules of logarithm. But let me see if I can do 1 or 2 logarithmic equation per se. But I'm going to bring the equation more to solve more of the logarithm. Just one more logarithmic equation or 2, and I will now go and make other videos for it. Now let's look at this question. 2 log x plus 2 is 8 is equals to log 2x plus 19 is 8. And you have to solve it. Now, I will wish to solve the simpler one, but this one I actually moved a little bit further. But I'll just make it easy, solve this one, and maybe the next videos I'm going to make it a little bit easier for you. Now, this thing, I'll just solve it just this. We have log x plus 2 raised to power 2. I'll bring this one forward because this can give me this 8 is equals to log 2x plus 19 is 8. And law of comparison, the powers are equal if the bases are equal. So we have x plus 2 squared is equals to 2x plus 19. You expand this, then you make it a quadratic equation and solve it. If you expand this, you have x squared plus 4x plus 4 equals to 2x plus 19. So when you correct like this, you have x squared plus 2x minus 15 is equals to 0. And you solve it quadratically, you get x minus 3 and x plus 3 equals 0. So your final answer will be x equals to 3 or x equals to minus 3. Then you can simplify it. But the next video I'm going to make, I'll make it simpler. I'll start from the little to the big one. But so far, go and master all the laws of logarithm. It will help you in the next question we are going to solve. Thank you, and God bless you so much.